Okay, so we're going to move on to reaction mechanism. Okay, so what is a reaction mechanism? It is basically a sequence of steps, right, which we propose in theory. Okay, whether or not it actually happens, nobody really knows that, but we propose the steps. It follows a certain logic, all right? Elementary reaction is a single step reaction. So the rate equation is basically the same as your stoichiometric equation. A non-elementary one, right, which is the more problematic one, it occurs by a multiple step mechanism. So the mechanism that we propose must satisfy both the rate equation and the stoichiometric equation. All right. So the overall order, all right, the overall rate of reaction depends on the slower step, which we will call rate determining step. Okay, let's look at this first example. Consider this overall equation, right? A plus 2b, you get C plus D. If the rate equation is given as rate equals to K concentration of A times concentration of B, suggests a possible mechanism that is consistent with the observed kinetics. All right, so we will suggest this two-step reaction, all right, where we will actually cancel out, okay, the intermediates. All right, and then the slow step, right, consists of 1 mole of A and 1 mole of B, which is consistent with the rate law. Okay, so this is how we suggest. Example 2, right? So they say blah 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 blah. All right, 2NO plus 2H2, you get 2N2 and 2H2O. All right, so we propose this mechanism suggests the rate equation. So the rate equation is basically based on just the slow step. All right, so just the slow step. Okay, but because N2O2 is actually an intermediate and not a reactant, we will need to base N2O2 on 2 of NO, all right, because NO is a reactant. So therefore, our final rate law is actually rate equals to K N2 square and H2 concentration. All right, so a practice question for you guys. You can pause the video here for a while to try out, to try suggesting a reaction mechanism. But if you don't want to, you're free to continue. Okay, so the rate equation, right, is not the same as your rate law, because if it was, your rate law will be H2O2 squared, but now it isn't, right? So we have to propose a mechanism for a non-elementary reaction. Okay, so we propose something which has an intermediate, all right? And a logical intermediate here will be just a single O atom, all right? So which we can actually just cancel out here, right? Then you will get back your 2H2O2 and 2H2O and a single O2. All right, so this matches with our rate law, which is 1 mole of H2O.